Welcome to section 4.2. We're dealing with graphing quadratic equations, and we looked in 4.1 at graphing equations in standard form, which is ax squared plus bx plus c, and now we're going to look at vertex and intercept form as well. So I'm going to start with the idea from section 4.1. If you take a look at this intro question, they're giving you a function negative x squared plus 2x minus 3, and we want to find the vertex. According to section 4.1, we can find the x-coordinate of the vertex by taking the opposite of b over 2a. And so what I'm going to do, the opposite of b is negative 2 over 2 times a. Let me try that again. Over 2 times a, which is 2 times negative 1. So I have negative 2 divided by negative 2, which is a positive 1. So the x-coordinate of my vertex is a positive 1. If I take that 1 and plug it back into my function, I get negative 1 squared plus 2 times 1 minus 3. So I have negative 1 plus 2 minus 3, which ends up being negative 2. And you can write down that work if you need. What I'm going to do is plot that point on my graph. So go right 1 and down 2. And I plot this point here. We learned in the last video also that the y-intercept comes from the value of c. So if I look at the value of c, it's negative 3, which means my y-intercept occurs at the point 0, negative 3, which is on the y-axis. So I go down to negative 3 and I plot my point. I also know that the axis of symmetry is the vertical line that goes through my vertex. And it always includes the x value of my vertex. So I have x equals 1. And don't forget, as we do this, we want to dot in that vertical line. And we learned that in parabolas, there's a mirror image on either side of the axis of symmetry. So because I have this point 0, negative 3 here, I also have the point 2, negative 3 on the other side. And I can kind of complete my parabola from there. We also learned that yesterday that the max and min value is the y value of your vertex. And so if we look at our vertex, my in this case, maximum value is negative 2 because everything else is below the y value of negative 2 when I look at my parabola. So that's a bit of review from section 4.1. So we're going to jump into the material for section 4.2, and we're going to start with this idea of vertex form. And this vertex form looks like this. Y equals a times the quantity x minus h squared plus k. Okay? Now, as we look at this, this all comes from the basic x squared graph, which we worked on yesterday. What it means is that you're translated, and I'm going to shorthand this a little bit, but left and right, and I don't know which way, but left or right units h, and up or down k units. Now, one thing to keep in mind, when you move left and right, it's always opposite of what we think, and that's kind of key. So circle, star, underline, whatever it is that you need, but it's always opposite of what you think. The vertex in this is the point HK. So it will tell you movements left, right, up, and down to get to a vertex. The axis of symmetry always goes through the x point of your vertex. So it's x equals whatever value of h we have is. If the value of a is positive, like yesterday, our graph will open up. If the a value is negative, our graph will open down. Okay, I also want to do one more stipulation that's not in here, but if a is greater than 1, then we consider this a stretch. If a is between 0 and 1, this is called a shrink. And the last thing, if a is negative, then not only does it stretch or shrink, but it also reflects over the x-axis. Okay, so when the value is negative, you're actually going to have two answers, the stretch or the shrink, and the reflection. Okay, so as we look at this, let's move up and let's actually look at a couple examples of this. We're going to start with example 1. Now, if you have a graphing calculator, you absolutely can plug this in. But my goal for this chapter is really to not have to use your graphing calculator very much. Now, I want to describe the transformation actually before I'm going to give the vertex or axis of symmetry. So, as I do this, I apologize for the pause there. As I do this, I want to look at left, right, up, or down first. This moves -1, which normally we believe goes to the left. In this case, though, in the parentheses, it's always opposite, so we're moving right 1 to begin. This -4 at the end is true to its number, and it's up or down. Because it's negative, this one is down 4. And we said the number in front told us a stretch or a shrink. Because this value is between 0 and 1, this is a shrink of 1/2. Okay, and what that means is it's going to take it closer to the x-axis. So closer to the x-axis. Now, this right and down will help me with my vertex. So as I look at this, I can see that if I go right 1, so I'm going to start at 0, 0, right 1, and down 4, 1, 2, 3, 4. Let's try and get the right point here. Over 1, down 4. This is where my vertex will be. So I have the point 1, -4. The axis of symmetry, again, is x equals, and it's always the x coordinate of my vertex, so x equals 1. I'm going to slide that in there as well. Now, to find the other points, graphing calculator people, you can look at your table, which we discussed yesterday in class. Those of you without the graphing calculator, what I'm going to do is, like section 1, I'm going to put in the vertex of 1, -4, and I'm going to look for points on either side. Well, lower than 1 is 0 and -1. Higher than 1 is 2 and 3. And then we can plot our points from there. So let me give you some good ones at least that I know. At -1, you get -2. And at 3, you also get -2 since it is symmetric. And then the other ones, truthfully, you can fill in by plugging in a 0. If I plug in a 0, 0 minus 1, go back to the original equation that's up here. 0 minus 1 is -1. -1 squared is 1. 1 times 1/2 is 1/2. And 1/2 minus 4 is -3.5. So -3.5 and -3.5. And you can plot these points as you go. And I'm going to go to the nice ones right now. Let's move over to up to. And you can see then this parabola. And you can kind of see, all right, here's a 0.5, here's a 0.5, and you can kind of make that parabola. Okay, again, those of you with graphing calculators, you're going to be able to get these points automatically from your table. But those of us without the graphing calculators will have to plug in values by ourselves. Okay, so let's try one more. I'm going to start again with the descriptions because I think it's easier to do that and then work backwards. This +3 at the end says go, let me actually do this correctly. It says go up 3. This +2 inside, +2 normally means to the right 2, but it's opposite, so it's left 2. The 3 itself is a stretch because it's bigger than 1, so stretch of 3. And the negative itself has its own description, and that is a reflection over the x-axis. Okay, now we said up and down and left and right always tell us our vertex. So let's start there. If I move left 2, I start at the origin, go left 2 and up 3, I have my vertex point at -2, 3. Which means my axis of symmetry is x equals -2, and I throw in my dotted line. Now again, you can, those of you with graphing calculators, put this in your y equals and go to table and get a value of points. However, many of us don't have that option. So in the middle of my table, I'm going to put my vertex of negative 2, 3. To go values smaller, I'm going to do negative 3 and negative 4. To do values bigger, I'm going to do negative 1 and 0. Okay, if I plug these in, let's start with 0. Inside the parentheses, 0 plus 2 is 2. 2 squared is 4. 4 times negative 3 is negative 12. Plus 3 makes negative 9. And if it's that value at 0, it also has to be that value at negative 4. So let's try it at negative 1. Negative 1 plus 2 is 1. 1 squared is 1. Times negative 3 is negative 3. Plus 3 makes 0. And so I have values at 0 on either side. And negative 9 is way down here, so I'm just going to make this skinny parabola. And I get this parabola that is reflected, and it's skinnier, which means it's a stretch, and it has a vertex of negative 2, 3. Okay, and so this is kind of one of the first ideas of what we're working on, and this is called vertex form. Okay, now let's flip the page. We're going to look at our second form called intercept form. All right, intercept form of a quadratic looks like this. Y equals, we still have that a again, but now I'm going to use two different values, x minus p and x minus q. And p and q are called intercepts. And another word for intercepts, just so we make it clear, intercepts, another word is zeros. And another word also is solutions. Okay, and those three words are going to be interchangeable as we go through this chapter. Now, the x-intercepts are these points, P0 and Q0. Make sure that looks like a Q. And these are spots where they hit the x-axis. And so this is points on the x-axis as we're going to graph. Now, the vertex is halfway. So to find the halfway point, the midpoint is what you used in geometry. To find the x value of the vertex, we take our zeros or our intercepts, p plus q, and we divide it by 2. It's like we're finding the average or the midpoint. The axis of symmetry then comes from the same thing, p plus q divided by 2. Same concept occurs. When x is greater than 0, it opens up. When x is less than 0, it opens down. So we're never going to change that idea. So I just want you to be aware as we go through. Now, let's take a look at a couple of these. What you're going to do in order to be able to find those values, and in my opinion this is the easiest way, is you take each set and you set it equal to 0. If I say 0 equals x plus 1 and x minus 3. We're trying to find the zeros. And if you look, the y is 0. And if you remember from chapter 2, to find intercepts, you make y equals 0. So that happens where x plus 1 equals 0. And that happens where x minus 3 equals 0. So I solve each of these, and I find that x equals negative 1. And if I solve the second one, I find that x equals 3. So my two intercepts should be written as points, negative 1, 0, and 3, 0. In order to find the vertex, we're going to go halfway between those two. Okay, now I'm going to plot these real quick. Negative 1, 0, 3, 0. Now you can do a little bit of counting your way through. The only thing is algebraically we're going to say we want to see it. So in order to find the x value, I take my intercepts, negative 1 plus 3, and I divide it by 2. Well, 2 divided by 2, if I add up the top, then equals 1. So my vertex occurs at 1 comma something. We know our axis of symmetry then is x equals 1. The problem is I don't know the y value, and the easiest way is to plug it in the factored equation. So negative 1 and I just threw the 1 out in front just because I like to see it personally, but I throw in a 1. 1 plus 1 times 1 minus 3. Well, if I look at it, then it's a negative 1 times 2 times negative 2. So negative 4 times negative 1 is 4. So the y value of my vertex then is 4. So I go to 1, 4, and I plot my point. And what you'll notice then is this is already my parabola, and I don't have to find any additional points because really you only need 3 points. I have the 2 intercepts and then also the vertex. So what we're going to do is try another one. All right, so here we go. 4 times x minus 2 and x plus 2. In order to find the x-intercepts, don't forget you make y 0. So 0 equals 4 times x minus 2 and x plus 2. This 4 in this case doesn't matter because I'm just setting each piece equal to 0. So I have x minus 2 equals 0 and x plus 2 equals 0. When I solve each of those equations, I get that x is 2 and I get that x is negative 2. What that means then is I have intercepts at 2, 0, and I have intercepts at negative 2, 0. So I can plot those, negative 2, 0 and 2, 0. And we know the vertex should occur halfway between them. Now, show your work no matter what. As I'm doing this, x equals 2 plus negative 2 all divided by 2. Well, 2 plus negative 2 is 0, and 0 divided by 2 is just 0. So my vertex occurs at 0 something. My axis of symmetry is x equals 0. And I could dot in this, let's try and actually get that on the line. I could dot in this x equals 0 line, the vertical line, which is the y-axis. To find the point, I plug it in. Here's where the 4 comes in handy. So I have 0 plus 2, and I have 0 minus 2, which equals 4 times 2 times negative 2, which is 8, negative 16. Now, as you look at our graph, the problem is negative 16 is not on our graph. So you will want to change the y-scale. And what I would suggest is we go by 2's this time. So 2, 4, 6, 8, 10. Is that going to do it for us? No, because I need 16. Okay, so let me try again. And this is, I'm walking you through kind of the process that we expect as you go through. If 2's don't work, do 3's work? I think so. Let's do it this way. 3, 6, 9, 12, 15. I'm going to go with close enough because I can put it right off there. And as I'm looking, it means it's negative 15 down here. So negative 16 is kind of like, let me see if I can make it big enough, right here. And I get this parabola that looks something like this. Now you'll notice the graph opens up because the 4 is positive. Okay. That also means there is a stretch of 4, and you can kind of see it's a little bit skinnier as it's going through, but nothing big. But this is kind of the idea as we go through. The last part in this section is to go from one form back to standard form that we looked in section 4.1. So what we want you to do is FOIL these first two. So I take x times x is x squared. X times 6 is a positive 6x. Negative 4 times x is a negative 4x. Negative 4 times 6 is a negative 24. I'm going to simplify that before I multiply by 3. So 6x and negative 4x is a positive 2x. And then I have this minus 24. And now I can distribute the 3 that's in front to all 3 of them. What I end up getting is y equals 3x squared plus 6x minus 72. And this is the same parabola in standard form instead of intercept form. Okay, and we will use all 3 forms interchangeable as we go. In part B, we want you to do the same thing. Now I'm going to cross off f of x because I know you don't like it. We're going to put a y there instead. Now I'm going to use FOIL in this because I've got parentheses, I've got exponents, I've got fractions. I'm going to start inside with the squaring. So I have this negative 1/2, and I'm going to square this. What that means is I take x plus 4 times another x plus 4. X and x makes x squared. X times 4 is a 4x. 4 times x is another 4x, so I end up getting 8x. And 4 times 4 makes 16, and then I have this plus 5 at the end. I'm now going to distribute my negative 1/2 because multiplication comes before addition. So I have negative 1/2 x squared. Negative 1/2 times 8 is negative 4x. Negative 1/2 times 16 is negative 8. And then I have this plus 5 still sticking out at the end. I can combine these two. So I get an equation of y equals negative 1/2 x squared minus 4x minus 3. Okay, so as we're going through, again, the last part that we want you to get is, can you go back and do some of the Algebra 1 things like FOIL and distributing and using order of operations? Okay, that's the end of section 4.2. Thank you for watching.